So I can actually turn all these on at once. Show them like this. Now, also I can step through this and look at the position and what the forces are at any point in time. So this is a really dynamic simulation of seeing what's happening. The thing that we normally like to look at is the maximum. So I can search for the maximum load, and this happened to be at times 0. So I can select that and very quickly I'll export this. And select that part and export this to the FEA. So what I've done is put loads on, don't put loads on, then I'll run the simulation to find out what the reactions are. Now I've got the reactions I've exported to the FEA, and so I can finish my dynamic simulation area and go into the stress analysis. And I need to create a simulation, and I will be creating a motion load analysis. It's already detected. I've got one part here that I exported and the time step. Just check I have the right level detail to bring this through into. So what it's doing here, it's actually adding the loads to my little link. So that's already brought in the moments and the reactions. So look at the loads here. Body loads, because it was time step 0, it wasn't moving, so we have no acceleration. But we can also see the two forces here, and we can actually look what they are, the 115 newtons and the moment. Did I get that right? The moment. At the moment. Okay, so once we've done that, I'm just going to skip over the FEA at this stage, go straight to simulate and run the simulation. And this will automatically mesh and to run simulation. And here, it's probably on the screen, I can't see my stress. Basically, I've got the stress, you can see the stress here. And the output. I might have to change the resolution because you can't see what stress we have there. So, bear with me. Don't have to. What were you running with?
Well, we're waiting by about 700. It warps the aspect ratio, but at least shows
480 by 720.
ish. Yeah, there we
You
go.
got that? Okay.
Aspect ratio is a bit off, but at least you can see it.
Okay. Okay, so we can see the stress. Okay, so as I said, the main part of the difference between 2009 and 2010 was the fact that we can actually find our joints much easier and do those sort of things. This kind of bring the forces into the FEA and run the FEA was available before, which is the single part of FEA though, which is largely what I've done here. So now we're going to the FEA. Now, as I said earlier, Autodesk by two companies. We actually mentioned the other board. Previously by Plasotech. Plasotech technology has been introduced into the 2010 product. Algor will be probably a vertical product on top, and so what we see in 2010 is incorporated into professional or simulation. So we get some basic functionality there, and then if we need to go further, we can always go to Algor. Now the first FEA I'll show would be the parametric FEA study. So this is where we might have several different combinations to try out. So plate widths and thicknesses. And rather than running a simulation, checking it, going back, running again, we can do it all in one go. So, just close this one down. part here, which is just a extrusion and a slot. And I'd like to do a some FEA on this. I'd like to just constrain one end and put a load on the other end just so it's a simple beam. And then I'll go a bit further of actually trying to say, okay, what's the optimum width and thickness of this beam, given minimum mass. Start the simulation, we start on the left hand side of the room and go to create simulation. And we just do a simple, straightforward, simple single point simulation. Swing from left to right, we'll have a look at the material. So this has got a style steel, which comes straight through from Inventor, where we've set up our styles. We have to look at the styles editor. And this is much what we've seen before, except we can actually change the units. So here we've got a unit strength of 207 megapascals. If we wanted to, now we can change to English stands. So if you want to have PSI and kips square inch, you know what a kip is? No. Kips 1,000 pounds if you do need to know. We'll stick to metric, I think. And so, very material. We now come across the constraints for a simple fixed constraint of this end. And we'll put a load on this end, which will give it a direction of going downwards. And I'll give it 8 kilonewtons. So we don't have to put in newtons here, we can actually just type in the units, saving lots of zeros. And now we've done our working from left to right, but our constraints, our loads come across, we don't have context because this is not an assembly. We'll look at the mesh. So the mesh settings here, decide to create curved mesh elements. So that would be as opposed to linear mesh elements, it's curved ones, or quadratic or higher order mesh elements to give a more accurate result. So we'll look at the mesh. This is given just our default mesh. Now, before we solve it, we'd like to be able to refine the result. So we'll put in here a maximum of 5 refinements. We're stopping if the result is converged within 10%. So in other words, if it runs one simulation and then runs the next one, and then within 10% of each other, then it will stop the simulation. We'll stop at that point in time. So we'll run this one now. And as you can see, it's very quick. But also we can see we've got a coarser mesh at this end and a finer mesh where we see the stresses changing in value faster. So where it's a high rate of change, then we get the finer mesh. And this is giving us a result, and that's all well and good, but really we'd like to minimise the mass on this. So we might like to change the width a few times and the height to try and find out the best solution. So rather than doing those one at a time, I'll just take this simulation, I'll just copy it. And this is a new thing that we can also copy the simulation, and so we don't have to start from scratch and put different criteria on. So the second simulation, I compare the properties of it and change it from a single point to a parametric, and we'll change the name of it as well. Now, because it's parametric, we can use this parametric table. So it has nothing at the moment. This also